Good day everyone, welcome again. Today we will talk about hydrogen and energy transition. I invited two colleagues of mine, Marijn Blommaert from our office in Antwerpen and Tobias Kaserer from our office in Schiedam. We will discuss some general aspects of hydrogen, but also some technical aspects. Marijn, welcome. Can you please tell about yourself and your role at KH Engineering?
Hi Serdar, thank you for inviting me today. As you said, my name is Marijn Blommaert. I'm a process engineer at KH Engineering, and my background is a PhD in electrochemical conversion of water into hydrogen, which is also our topic of the white paper. And this knowledge I apply to our industrial projects here at KH.
So Marijn, can you tell us please about the second white paper of KH Engineering and the place of hydrogen in the energy transition according to your expertise?
So the subject of our white paper is the production of hydrogen, and in particular the green production of hydrogen. And that is a very hot topic that we also see within our clients. We have some ongoing projects which we'll talk about later, but also just regular questions like how does this work? Should we apply it in our projects, in our industrial sites, and so on. And hydrogen will have a certain role in the energy transition, as it can provide seasonal storage, for example, or other applications for the production of new components like methanol, for example. So it's definitely something to look at.
And what kind of green production technologies are there for hydrogen?
The most common technique for hydrogen, green hydrogen production, is via electrolysis, which is a technique that allows to store electricity in molecular bonds like hydrogen. And currently we're producing our hydrogen via natural gas. So that means that every kilogram of hydrogen that we produce, we're also emitting 16 kilograms of CO2. And so that adds up to the global warming. So by using a system like electrolysis, especially if you use renewable energy, you will be climate neutral and avoiding CO2 emissions.
As we are talking about electrolysis now, I want to turn to Tobias. Tobias, can you please tell about yourself and your role at KH Engineering?
Thank you, Serdar, for inviting me. My name is Tobias Kaserer. I work for KH Engineering now for 10 years as a lead engineer electrical. I've been involved in many projects, also once with electrolyzers, so I have some experience with that.
As Marijn also told us, electricity is used in electrolyzers to separate water in different molecules, hydrogen and oxygen. Can you tell us how is this electricity supplied to these electrolyzers units?
For electricity, you need an energy source, and that can be either coming from the public grid or from your own energy source, such as solar panels or a wind turbine. And as your electrolyzer stack usually works on low voltage, DC, direct current, you need some equipment to convert the high voltage alternating current AC, which is available on the grid and usually in your own energy source, to convert it back to low voltage DC. So you need some equipment, at least a transformer, to convert from the high voltage to the low voltage, and then you need additionally a rectifier to transform from AC to DC. But it's not only an electrical stack that you need, there's also some balance of plant equipment involved, such as a gas separator or purifier, but also some auxiliary equipment for the plant, and that usually works on low voltage AC.
So what is the current status of hydrogen production with electrolyzers? Who are the big players on the market and what are the challenges?
So there are two main technologies in the electrolysis field. We have, on the one hand, we have alkaline electrolyzers, and on the other hand, we have PEM electrolyzers. And we see that those two technologies go hand in hand, or they at least have the space to develop themselves. We also see that in the projects that have been announced in the Benelux. For example, Antwerp has announced a 100 megawatt electrolyzer factory, which will be done by plug power. And for example, in Rotterdam, there is at the Maasvlakte, there is Shell that's going to produce 200 megawatt. And even bigger, ICC will make a 500 megawatt plant in Amsterdam.
There are some challenges because one of the challenges is that the national and regional grid in both Netherlands and Belgium is quite congested, which means that the energy cannot be supplied to new, bigger consumers. And we're talking here about hundreds of megawatts. So that will require an upgrade of the electrical grid. And those projects usually take at least 5 years. So that's one. Another one is that the electrolyzer equipment is now being fully developed by the vendors, and also means for the engineers and also the client, there's no ready information available to base its design on.
Yeah, and that's where our role takes place.
Exactly. Yeah.
So there are a lot of challenges. How can we overcome these challenges, Tobias?
Yeah, for the lack of capacity in the electrical grid, there are some challenges which are now being researched. One is to have no grid connection to the public grid at all, which means you use your own energy source. If you want to produce green hydrogen, you use a renewable energy source for the production of hydrogen. This island mode does require a higher level of controllability to create a balance between power generation and available power. There's another option being researched, and that's to have a grid connection to the public grid, but to help by throttling the power of the hydrogen production to create a balance between energy available in the grid and energy consumption by hydrogen production. And this is called peak shaving.
What are the advantages of hydrogen as an energy carrier, and how do you see the future of hydrogen?
So one of the applications is long-term storage. And so that also relates to the peak shaving. Seasonal storage production, for example, high production of renewable energy in summer can then be used to store via hydrogen for further applications in the winter, for example. Another application that I value highly is the production as a commodity for the chemical industry. For example, if you use hydrogen and CO, you can make products like methanol. So you make green methanol, or you can use it as a product for further upgrading up to plastics and so on. So many possibilities here.
So Tobias, what is our experience in this subject?
We've done multiple projects with electrolyzers already for many years, and we are currently also working on a project. We're now in the basic engineering. I'm the lead engineer for the electrical part of that. And it is great to be one of the few companies at the forefront of developing these technologies. We have a unique position that requires us to bring together all the parties involved, so like the client, the vendors, but also the system operator, to create a system that works.
Thank you, Marijn and Tobias, for sharing your expertise and knowledge on this subject. It's indeed a really important topic at this moment, and that's why we chose this subject also for our white paper. If you're interested in the subject, please go and download our white paper on our website. We'll be publishing more white papers in the future, so please keep on following us. Till the next time.